Hello friends, welcome to edupediaword.com. In this video, we'll be continuing questions on circles. The first question shows a circle along with some straight lines. It says that tangent xy is parallel to tangent x dash y dash. That is, these two tangents are parallel. Also, AB is another tangent to a circle with center O at C. Here, the information provided is that the circle is having center O and AB is tangent at the point C. PQ join point of contacts of xy and x dash y dash. This line PQ is joining the point of contacts of xy and x dash y dash with circle. We need to prove that angle AOB is 90 degree. This angle is needed to be proved 90 degree. So let us start with the solution of this question. Let us first join O with C. On joining O with C, we can see that OP, OQ and OC are all the radii of same circle because they are joining center to the point of contact. And thus we can say that OP is equal to OQ is equal to OC. Now let us concentrate on the quadrilateral PACO. In this quadrilateral we have two triangles, that is triangle POA and triangle COA, where P and C are point of contacts and O is the center of the circle. In these two triangles we can see that AO is a common side to both. Therefore, AO equals AO in both the triangles. Also, OP is equal to OC from here. That is common radii or radii of same circle. Now, if we concentrate on the point A, we can see that from A, two tangents AC and AP are drawn. Thus, we can say that these tangents are of equal length. That is, AP is equal to AC, because lengths of tangents from an external point are equal. Now we have three sides equal in both the triangles, and thus we can say that triangle POA is congruent to triangle COA by SSS congruency criteria. Now, since the triangles are congruent, their corresponding angles will be equal. Now, the angle of our interest is AOB, and AOC is a part of this angle. Now, let us label these angles as 1 and 2. 1 plus 2 will give us the complete angle AOB. Now, the triangles which we have proved congruent involve 1 and this angle, which let us label 3. Similarly, let us label this angle as 4. Now, by this equation, we can say that angle 3 is equal to angle 1 by corresponding parts of congruent triangles. Similarly, if we concentrate on the lower quadrilateral OCBQ, we can say that angle 4 is equal to angle 2 by carrying on the steps as similar to the above steps. That is, this side will be common to both, the radii will be equal, and if we take point B as an external point, then BC and BQ, the length of the two tangents, will be equal. So now, since PQ is a straight line, therefore this complete angle will be 180 degree. That is, since PQ is a straight line, therefore angle 1 plus angle 2 plus angle 3 plus angle 4 will be 180 degree. But from here, equation 2, angle 3 is equal to angle 1. So we can say that angle 3 can be replaced by angle 1, and similarly angle 4 by angle 2. This will imply that twice of angle 1 plus angle 2 is equal to 180 degree, or angle 1 plus angle 2 is 90 degrees. Now friends, angle 1 plus angle 2 is the complete angle AOB. So, in other words, we have proved that angle AOB is 90 degree. Hence, the given to prove part has been proved. Now, let us discuss another question. A statement is given: opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles at the center. Prove. So we need a quadrilateral circumscribing a circle, which we have drawn over here with center O. We need to prove that opposite sides of such a figure subtends supplementary angles at the center. Let us first label the sides. Let the quadrilateral be ABCD. Now let us pick up one side as AB. Then the opposite side will be CD. Thus, angle subtended by AB at the center will be Similarly, the angle subtended by DC at the center will be Let us label these angles as one and 2. we need to prove that opposite sides subtend supplementary angles at the center. That is, the sum total of the angles subtended by opposite sides are supplementary. By supplementary we mean 180 degree. Now, for proof of this question, of this statement, let us first label the point of contacts of different sides with circle as P, Q, R and S. By quadrilateral circumscribing a circle, we mean that the quadrilateral is touching the circle at specifically 4 points. Now let us join the center with the touching points. Let us label the new angles formed. Clearly the angle 1 is further divided into 2 angles. Let these angles be 3 and 4. Similarly, let angle 2 be divided into 5 and 6, and the remaining angles formed be 7, 8, 9 and 10. Now in other words, we need to prove that angle 3 plus angle 4 plus angle 5 plus angle 6 for angle 2 is 180 degree. Friends, for proof of this question, let us first concentrate on the vertex A. Between vertex A and center O, we have 2 triangles. That is, in triangle ASO and triangle APO, we can see that AO is common to both. Now OS and OP are radii of same circle, therefore they will be equal. Now if we consider A as an external point with respect to the circle with center O, we can see that AP and AS are in fact 2 tangents from the point external, that is A, because AB is touching the circle specifically at a single point, that is P, and similarly for AD. Thus we can say that length of such tangents will be equal, that is AS is equal to AP, because length of tangents from an external point are equal. Thus we can say that 3 sides are equal, or triangles are congruent by SSS congruency criteria. Once the triangles are congruent by corresponding parts of congruent triangles, we can say that the corresponding angles, that is 7 and 3, are equal. Thus we have concluded that angle 7 is equal to angle 3. Similarly, on concentrating at point B, we can prove that angle 10 is equal to angle 4. And while working on point C, we can prove that angle 9 is equal to angle 6. Similarly, for point D, we can prove that angle 8 is equal to angle 5 by following the same procedure as done here. Now friends, if we look at all these equations specifically at their right hand side, we can see that their right hand side contain all the angles that we need to prove their sum as 180 degree. Thus, let us first label these equations. Now friends, we know that the complete angle is always 360 degree. Now the complete angle is formed by 3, 4, 10, 9, 6, 5, 7 and 8 angles respectively. Thus we can say that angle 3 plus angle 4 plus angle 10 plus angle 9 plus angle 5, 6, 8 and 7 are all equal to 360 degrees. Now let us bring together the angle we need. Angle 3, 4, 5 and 6. And the remaining angles are angle 10, 9, 8 and 7. Now from these equations, we can substitute different values for these angles, and they will become, in place of 10 it will be angle 4, in place of 9 angle 6, and for 7 and 8 it will be 5 and 3. So all in all we will be having angle 3, 4, 5 and 6. Thus we have both these quantities in between the brackets same, or we can say that twice of this quantity is equal to 360 degree. In other words, angle 3 plus angle 4 plus angle 5 plus angle 6 is equal to 360 degree divided by 2, that is 180 degrees. Or we can say that angle 1 plus angle 2 is 180 degree, because 3 plus 4 was angle 1 and 5 plus 6 was angle 2. Thus we have proved the two proved part, that is angle 1 plus angle 2 is equal to 180 degree, or the sides AB and the side opposite to it CD subtend supplementary angles at the center. We can similarly prove that these two angles, that is angles formed by BC and AD, the opposite sides, let these angles be x by, we can also prove that these angles are also 180 degree by the same procedure. So friends, these were some questions on circles. Thanks friends for watching Edupedia word videos.